Hi there. I'm going to give some tips for those 4 questions that I sent out for the university's assessment quiz that they want us to give you. All right. First question. Now I'm going to try to get you started here. That's what I'm going to try to do for most of them. So don't expect me to go through the whole thing. I'm going to take you to a certain point, and I'm hoping maybe you can carry it through the rest of the way. Now, first of all, where's the mark? Okay, there's the mark. So, to begin, we've got that formula split on the 2 lines. So let's put this in a prominent place. So there's our demand function. Remember, it's the demand function because this is the unit price for whatever item it is. And what we've got here are 2, you could call them scenarios maybe, or 2 ordered pairs in a way. So when the price is $50 for this particular item, we can sell 1,200 of those items. If we change the price to $45, we can sell 1,500 of those items. Now the question says solve for C and K in the model. This might be what actually throws you, but actually it's not that difficult. Because remember, we've got ordered pairs here. So we're going to write this formula down twice with those 2 sets of numbers. So for the first one, we'll call this the first set. And so first P equals CEKX. So we put those numbers in there. So the price is $50. C we don't know yet. E, of course, is a constant. K we don't know yet, so we'll leave that as K. And X for that particular ordered pair is 1,200. So we can write that as 50 equals C E 1,200 K, if you'd rather look at it that way. Now the next thing I'm going to do is I'm going to solve this for C. I'm going to divide both sides by the e to the 1,200k. So that gives me C equals 50 over e to the 1,200k. Okay, hold on to that. We'll go to the second order pair now. This one gives us 45 for the price equals C, we still don't know. E is a constant. And this time we have K times the 1,500 units. We'll rewrite that as 45 equals C E to the 1,500K. As before, for the other one, we'll solve that for C, divide both sides by the e to the exponent, and we'll have C equals 45 over e to the 1,500k. Now, the reason I solved those for C is because now we have 2 expressions for the same value as C. So if I combine those, C of one, same C for the other one. So 50 over e to 1,200k equals 45 over e to 1,500k. Now we can cross multiply, and I'm going to steal a little bit of space in here. I'm going to cross multiply, so we'll have 50 e to the 1,500k equals 45 times e to the 1,200k. Now we want k, So next thing we can do is we can divide both sides by 50. So on this side we'll have 45 over 50. That's good. We're also going to divide both sides by this e to the 1200k. So over here we'll have e to the 1500k over e to the 1200k. I hope you see what's coming. Now we'll move up here. And on the right hand side, we'll start with the easy part first. And that actually turns out to be 0.8 or 0.9, excuse me. On the left side, we've got the same base, so we can just divide, which means we'll subtract the exponents. So on the left side, we'll have e to the 300k. Now, what? Of course, take the natural logarithm of both sides. And now we have 300k because e and the natural log are inverse operations. On the other side, just rewrite natural logarithm of 0.9. So k equals, and we can get an actual number here, the natural logarithm is 0.9 over 300. Now, here's where I'm going to let you do some of the work from here on, because whatever this number is, I'm not going to grab my calculator and figure it out. You can do that. What I would suggest on your calculator is when you get this number, hit the store button so you'll have this number, whatever it is, store, and store that in X for the time being. Now, with that number stored in X, you're going to go back here, and we've got two different expressions for C, so we can actually figure out what C is. Let's take the closest one, this one over here. So now you can, to get C, you can take the 45 and divide it by e to the 1500 times the value of k. Now if you took my suggestion and stored it into X, you can just put an X there, and that will tell you what the value of C is. I hope that helps. Now, that takes care of the first part. Now it says find the values of X and P that will maximize the revenue for this product. So what I would suggest is, I think I'm going to clear this. So let's get some more space here. Erase all the ink. So what I would suggest is take these two values, C and K, and maybe make them something that's easier to handle. For example, I think this first one is an integer, point, some decimals. So you might want to just use that for your C, and K, make it 0. I think it's something like this, and maybe keep 3 digits out here. That's just to make this next part a little bit easier. It says find the values of X and P that will maximize the revenue. Well, just a quick reminder, revenue equals the number of items times the price. So you'll go back up here to this formula. Let's rewrite this. P equals CE to the KX. Multiply X times both sides, and you get R equals X C E K X. Now, the X you don't know. You do know what C is, so you can write this in. I don't have it right off the top of my head. That's something you can take care of. Also, this K, you can put that value in you just found. take this formula for the revenue, and since you want to maximize the revenue, you're going to take the derivative of this whole thing, d dx, and then the next thing is you take this dr dx, set it equal to 0, and you can find what the x value is and maximize it. Now let's see. Okay, so that will give you the x. You also need the price. Well, you've got a formula for the price. So once you've got x, all you need to do is go back up here, put the value of x in with the c that you know, the k that you know, everything's there. All you have to do is use the calculator and you'll have the price. That's number one. Moving on. I hope that helps. Now it will take some time because the derivative involves the product function and so on, but if you give it a real good shot, I think you can do it. Okay, number 2, continuous compounding. So you're going to start a scholarship fund at your alma mater, USC Upstate hopefully, and you're going to give a $25,000 scholarship annually. That's important right here. And you have $400,000 to start the fund. Is that enough to fund the yearly or annual $25,000? Well, right off the bat, let's get this formula. I think I mentioned it in class before. Here it is. A equals, this is the amount that you have after a certain time. E to the RT. And there's your formula for the amount, not the interest, just the amount. Now, what you're going to do is you're going to take A equals, and we're going to check out and see whether this $400,000 is enough. 400,000 is the principal or present value. E, of course, is E. The rate, got right here, that's the annual rate. So make that 0.06. Make sure you put the decimal point in there. And T. Now, T is going to be easy because you want an annual scholarship. So every time they look to make the scholarship, they're going to have 1 year's worth of money left there. So you can do this. Now that gives you how much is there after the first year. But you don't want to touch the $400,000. You want that to stay. So what you need to do is get it out of the interest. Well, what's the interest? We've got the amount that's there after 1 year with this 1. How do you get the interest? Very simple. You put $400,000 in, you got this amount out. So the interest equals the amount you just calculated down here minus the $400,000, which is the present value or the principal. This will tell you how much is there at the end of every year. What you have to figure out is this $25,000 or more? If this, for example, came out to $26,000, then it's no problem. Every year you get $26,000, you can fund the $25,000 scholarship. If it turns out to be $21,000, it's not enough, and you'd have to dip into the $400,000, and that's going to start dropping until the point where you don't have any money to fund the scholarship anymore. Okay, that's number 2. You should be able to knock this one out. Even if you can't get any of the other ones, you should be able to get this one. All right. Now we'll get a little bit more interesting. So we're talking about airline revenue on this one. You're familiar with the revenue by this time. You've got the straight revenue function. You don't have to create it from the price or demand function. And you've got it split into 2 different time intervals, from 2012 to 2016, this is your model. From 2016 to 2021, this is your model. T is going to represent the year, where T equals 12 represents 2012. First of all, you want to graph this model. So my suggestion on number 1 is take this first formula. That's for 2012 to 2016. If you're, let's say you're using a pencil to graph this, okay? And you graph the R equals negative 0.055 t squared plus 1.78 t plus 0.35. Remember, those are billions of dollars. So this is quite a bit. Now, what I would do is this. If I could do that in pencil, maybe you could even use your calculator to do that, or you could use some calculus to figure out where it turns around and all that sort of thing. If you can graph this with a pencil, graph the whole thing, and it probably is going to look something like that. What you would want to do then, because you've done it in pencil, you can do this. You only want it for 2012 to 2016, or 12 to 16. So what you can do is this. I'm going to change this to an eraser. So what you can do is you can erase, oh, I guess it erased too much. You can erase everything. Let me get the pen back. There, here's the pen. Erase everything before 2012. Erase everything after 2016. Now, you can go back and you could put in ink what remains after you've erased the years that don't relate to that formula. Second, you need the part that corresponds to 2016 to 2021. So graph this one again in pencil. In fact, while you're doing it, you might notice that you've already got the first part in ink. So that would be your starting point. So if this one looks like that, for example, and stops there, then you would only graph this part right here from 16 to 21. So that might be a help. Or you can just do the whole thing in pencil, then erase everything except the 16 to 21 part. And there you'd have number 1. Now, part 2. Let's go back and clear this out. Okay, there we go. Now we're going to look at number 2, or part 2. It says, suppose the revenue from 2016 to 21 followed the model for 2012 to 16. So what you're going to do is you're talking about 2016 to 2021, but previously you would use this formula. This says you're going to use this model instead. So you'll use t equals 16 and down to t equals 21. And for those, you're going to use the second formula up here, negative 0.2260 t cubed plus 7.234 t squared minus 75.04 t plus 256.7. Now, what it says is, how much more or less would the revenue have been for the airlines in 2020? Well, 2020 would be t equals 20. And since it's between 16 and 21, you're going to use this formula instead of the previous one. But what you're going to do is you're going to take this formula right here. Ooh, did I say the wrong one? Yes, I did. Ooh, sorry. This should be that. Sorry. I should restart, but I don't have the time. So you're going to use this. You're going to use it. Use the model for 12 to 16. So what you're going to do is you're going to take this t equals 20 and you're going to see what it would have been with the original model. T equals 20, and this is with the old model. And then you're going to use t equals 20 for the new model, which is from the first 5 years. And see how these R's, the R for the old model and the R for the new model, how they compare to each other. Are they close? Is one greater than the other? And that's the whole idea of number 3. All right, we're doing pretty well so far. Let's see how we can do with number 4. All right, remember these are just tips, so let's see how I can help you on this one. So net profits, talk about P, talk about millions of dollars, and I made up this one, Express Gourmet, 2012 to 2021. And here's what you've got. These are the actual values. And these are the actual values, and this is the model. So what I would suggest is take what you've got up here. This is the actual. And take this model and make another line that tells you what these values are. So for this one right here, you're going to take this model, P equals 200 e to the 0.150t. For this one, t equals 12. So you put a 12 in where this t is, and you'll take the result and you'll put it in there. Then you'll take 13, put it in this model, and put your result right here. Do the same thing, 14, 15, 16, 17. The idea is to see how close the model comes to real life. That's part A. Check. Find the linear model for the data. Now, pardon me a second. Okay, I'm back. Now, it would be quite difficult for me to show you the calculator. I'm going to use a TI-84, and if you've got a different one, stop by the office and I can show you how this part can be done with a different one. It says find a linear model for the data. So I'm going to tell you the steps. So first of all, I'm going to clear this slide so we can see what's going on. There we go. So we're working on this one now. You want a linear model for the data. So how do you do that? First of all, for these years, you're going to put 12 for this one. Oops. You put a 13 where this one is. You get the idea, 14. And just a 21 for that one. Now what you're going to do is this. So follow my instructions. You might want to write these down and hit pause as often as you need to. First of all, you need to tell the calculator what you've got. Up here, you've got 12 through 21. So, let's see how much I can put on here. So on your TI-84, once it's on, hit the Stat key, which is toward the middle, and you want to use the Edit menu, which is number 1. So you can just hit number 1. And what you need to do is put the years as 12, 13, 14, all the way up to 21 in L1. That's the first list on the left. to 21. When you've got that finished, move over to L2. In L2, you're going to put the profit in millions. In other words, you're going to type in L2, you're going to put 340.8 on the first line, 417.7 on the second line, and so on. Remember, these go into L1, these go into L2. Next thing, double check. If possible, ask someone to double check it for you. Make sure all your numbers are there and they're correct. Make sure it's a 340.8 and not a 348.0 or something like that. Make sure they're correct. Otherwise, everything goes downhill from here on. All right, you've got those numbers in there. What's next? Well, next, let's go back down here. Next. So let's say this is A. Part B. You're going to tell the calculator, hey, how about taking that data I just put in and get a model for me? A linear model. Remember, linear model. So here you go. You're going to go back to Stat again. You don't even have to go back to the main screen, just hit Stat. It'll start over for you. Now you need to go over to the calculator submenu, cursor over, and all you want is number 4, option number 4. Option number 4 is called Len Reg. That stands for linear regression, but linear model is what we want. And this version of it, because there are two, but we'll stick with this one. This is the AX plus B version of this model. When you hit number 4, you're going to be asked to enter some things. If you have a TI-83, you might have to put these in separated by commas. So first of all, you need to tell it where the X list is, and you're going to tell it L1. If L1 is not already there, just hit second 1 and it'll put an L1 there for you. Next, you want to tell it what the Y list is. Here, you need L sub 2, list number 2. If it's not there, put second 2 and now put an L2 there. Third, it says, how about giving me the frequency list? Well, because each of those is a single ordered pair, you can actually leave this blank. Don't type in blank, just leave it blank. If it's not, just clear it out. And store regression equation. You don't actually need to put anything there. I think I'm going to leave it at that to keep it from becoming more complicated. If you take statistics at some point, like Econ 291 or 292, I can tell you exactly what to do with that and how to use it. It can be handy, but right now you don't need it. So you're going to move down to the last line, and let's see if you can see this. It says calculate, and let's bring it up here. Calculate. Move down here, hit enter, bingo, you've got some results. Now, to talk about the next part, I'm going to clear the screen again. Of course, you can always back up if you need to. Erase all ink on slide, good. All right, so what do we have now? On your screen, what you have is at the top, it says linear regression. That's what you just did, or that's what it did. And it tells you which kind of linear regression you did. You did the ax plus b type. That's actually just the way the equation is going to be built. Next, that's what the equation looks like, but you don't know what the a and b are yet. Coming up, it tells you what a is, and for this one, well, for what I've got in there right now, mine says negative 0.686, and I'm going to stop there. There's some more though. B, 11 point, I'm just going to take 2 places there, 4 decimal places, and then you might or might not have r squared and r. Now, r and r squared can actually tell you how good a model this is. If this r is close to 1 or close to -1, then put it this way: your model deserves a smiley face. If your r value says something like 0.3 or anywhere close to 0, you probably don't have a really good model. You might try something else. Now what you're going to do is you're going to take a linear model, and you've already got what the equation is. You can put x values for 12 through 21 one at a time in that equation and find out what the values are, how it's predicting these numbers, and see how close these predicted numbers, these linear model numbers, are to the real actual profit. How close is this to the 609.3? How close is this to the 44,114.8? That's what it means. Now, part C says, okay, you've got the numbers in there. There's another thing you can do. In fact, there's several options. You've already got the numbers in L1 and L2, the years and the profit. Now, what if you wanted to experiment and see if you could get a better model? Well, the way you can do that is we'll do something we did just a little bit ago. Go back to Stat, over to Calculate. This time, let's see, where is this? This time we're going to go to 0, which is an exponential regression. And if you do that, it's going to ask you for the same things. Where's the X list? And if you've been following along, it probably already says L1. Where it says Y list, it probably already says L2. And the store regression equation, frequency list should be a big blank, and store regression equation probably is a blank. Now here's where I'm going to throw something in that you could have used for the linear model, and you can try it for the exponential model. When you hit that calculate, you're going to get an r and an r squared for this exponential model. And the closer the r squared is to 1, the better the model. Now what if you actually wanted to use this model to predict profit? Well, here's what you can do. After you put L1 and L2 in, blank out the frequency list, you could put y sub 1 here in the store regression equation. How do you do that? This is how you do it. So you move down here to store regression equation, store regression equation. Now how do you get that going? Well, once you're in this position right here, do this. Hit the vars key and then move over to y vars because you want to use that y sub 1. Once you get there, you want to use the first one, which is the function type of y variable. So just hit a 1 there, and then we just want the one at the top of the list. So you can just hit enter, or you can hit the number 1 and get y sub 1. As soon as you do that, it's going to fit this in. Then you can go down to calculate, and you've got this in your calculator ready for you to use if you want to. Now what good is that? Well, instead of making an equation and filling in the equation for all these different results, you can go back the same way I did here and pick up y sub 1 again. It'll give you y sub 1 in left parentheses. And what you can do is, if you want to find out what the prediction is for the profit, you can put the 12 in there, close it off, and what it's going to do is, because you stored that equation in the calculator, this 12 is going to go into the equation and give you a result. So in my case, let me get caught up here. So what I'm going to do is I'm going to get y sub 1 on mine, and I'm going to put a left parentheses, I'm going to put 12 in there, right parentheses, hit that, and for my numbers that I have in here right now, I get 2.27, and that would be in millions of dollars. Of course, I've got a different model. I've got some other junky numbers in mine, but that's how you could do it. And then if you want to find it for 13, you can just cursor up, change this 12 to a 13, hit enter, and you get your next number. Go up to this again, change this to a 14, you got the next number, and so on. Anyway, that is number 4, and that's part C, and you can see which model is a better fit. You could look at the R values for both of those, and that would give you a real good idea. You could also check the numbers that come out from those equations that you generated. If you use both of those models, how do you predict 2025? Well, if you put that y sub 1 in, as I showed you how, you could take, first of all, you could take your linear model. Remember, that was the y equals mx plus b model. If you still got that written down somewhere, we want it for 12, so you'd have y equals m, whatever that was, 12 for that year, plus whatever b was for that linear model, and that would give you a prediction for the linear model. And you can do the same thing for the exponential one. Now, if you had actually kept all that information, you could have used the first one to get y sub 1 and save that as your linear model. And then instead of using y1 again, you could use y2 for the exponential model. And you could actually compare them using 12 for one, 12 for the other, 13 for one, 13 for the other, and see how they match up with the actual profits. Well, that's about all I can do for right now. I hope some of that helps, especially for number 2. I know you can do number 2. Number 1 is tough. It takes a bit of time. Number 3 is possible. Give it your best shot. Okay? Well, until tomorrow morning, I'll see you.